The Cambrian Period. 542 to 485 million years ago. The Cambrian Period is the first period of the Paleozoic era. Spanning approximately 541 million years ago to 485 million years ago. It is one of the most critical periods in Earth's history. Famous for the Cambrian Explosion. A time when multicellular life exploded in diversity and complexity. Key characteristics of the Cambrian Period. The Cambrian Explosion. Within a relatively short geological time, complex multicellular organisms emerged and rapidly evolved. For the first time, many major animal groups, such as arthropods, echinoderms, and chordates, appeared on Earth. Notably, animals began developing hard structures like shells and skeletons, improving protection and mobility. Diverse ecosystems. Most life was concentrated in the oceans, with organisms living on the seafloor, floating, or swimming. Food chains became more complex, with the emergence of predators, filter feeders, and detritivores. Rich fossil record. The Cambrian period left behind a vast number of fossils, due to the development of hard parts like shells and skeletons. Famous fossil sites, such as the Burgess Shale in Canada, provide detailed insights into the life forms of this period. Environment and geology. Continents during the Cambrian were mostly fragmented into smaller supercontinents. The climate was generally warm, with no ice caps at the poles. Representative organisms of the Cambrian period. Trilobites. Prominent arthropods with hard exoskeletons and remarkable adaptability. Hallucigenia. A bizarre creature with spines on its back. Anomalocaris. One of the largest predators of the time. Opabinia. A peculiar organism with 5 eyes and a flexible trunk. Pikaia. One of the earliest chordates and a distant ancestor of vertebrates. Significance of the Cambrian period. The Cambrian period marks the beginning of complex life on Earth. It is the time when most major animal phyla appeared, laying the foundation for the evolution of modern organisms. The Cambrian explosion also helps scientists understand how life transitioned from simple to complex, providing invaluable insights into evolutionary history. Trilobites, the ancient explorers of the oceans. Trilobites are an extinct group of arthropods, Arthropoda, that lived approximately 521 to 252 million years ago. From the Cambrian period to the end of the Permian period, they were one of the most successful and widespread groups in Earth's history. With over 20,000 identified species from fossil records. Morphological characteristics. 3-part body structure. The name trilobite comes from their body structure, which consists of 3 longitudinal lobes. The axial lobe in the center and 2 pleural lobes on either side. The body is also divided into 3 horizontal sections. Cephalon, The head segment containing eyes, mouth, and sensory organs. Thorax, the segmented and flexible midsection, aiding in movement. Pygidium, the hardened tail section, often less flexible. Exoskeleton made of chitin. Trilobites had a hard exoskeleton made of chitin and calcium, providing protection against predators. Complex eyes. One of their most distinctive features was their highly advanced compound eyes, made from calcite, offering exceptional vision. Legs and antennae. Underneath their body, trilobites had jointed legs for movement and feeding, as well as sensory appendages like antennae. Lifestyle and habitat. Habitat: trilobites primarily inhabited the ocean floor, thriving in environments ranging from shallow coastal waters to deep-sea regions. Some species were free-swimming, while others burrowed into mud or sand. Diet: they were omnivores, feeding on organic debris, plankton, and occasionally preying on smaller animals. Movement: most trilobites crawled along the seabed, but some species were adept swimmers due to their flexible body structure. Significance in geological history. Index fossils. Trilobites are among the most important index fossils, aiding scientists in dating and understanding the environmental conditions of ancient rock layers. Early arthropod evolution. As one of the earliest groups of animals with complex body structures, trilobites provide valuable insights into the evolution of arthropods and ancient ecosystems. Diversity and adaptability. With tens of thousands of species, trilobites demonstrated remarkable adaptability to various habitats over hundreds of millions of years. Causes of extinction. Trilobites began to decline during the Devonian period due to competition from emerging groups like jawed fish. They became completely extinct at the end of the Permian period, around 252 million years ago, during the largest mass extinction event in Earth's history. Legacy of trilobites. Today, trilobites remain one of the most beloved fossil groups among collectors and scientists. They not only help reconstruct Earth's evolutionary history, but also symbolize the wonders of natural diversity.